This is the answer key to your first review for the quiz. Basically, for the first question, you're just finding the slope between 2 and whatever the time interval is. So the first one is the slope between 2.5 and 2, second one's 2.05 and 2, third one's 2.01 and 2. And you simply do the calculations by plugging in 2.5 for t and subtracting f of 2. We kind of went over this in class, so hopefully this all makes sense to you. For b, you have to do the difference quotient, where x is 2, and you simplify, and you can see all my work here. When you get down to the last step, where the h's cancel out, you plug in 0 for h, so you end up with 2 times negative 17 minus 0, which gives you negative 34 feet per second. And remember, we talked in class about how the slope of the secants as you get closer and closer and closer to 2 start to approach your instantaneous velocity at t equals 2. So these are all approaching negative 34. For number 2, it's simply a substitution because there is no asymptote at x equals 3, so your answer is 9/2. On the next page, the limit as x approaches 1 from the left, we're going to substitute into the first function because that's, oops, I lied. Substitute into the second function because that's where all the numbers are smaller than 1. So as we come from the left, we want the numbers that are smaller than 1. Plug in for x and you get that the limit as x approaches 1 from the left is 3. As x approaches negative 1, well, we have to check that from the left and the right. So negative 1 from the left, we're going to plug into this function, and that gives us 1. Negative 1 from the right, we're going to plug into this function, which also gives us 1. So since the limits from the left and the right are the same, the limit as x approaches negative 1 is 1. The limit as x approaches 1 from the right, we're going to plug into the bottom function because that's where all the numbers are bigger than 1, and we get 3. So therefore, since the limit from the left, the limit from the right are both 3, the limit as x approaches 1 is 3. Part E, use the definition of continuity to determine if it's continuous. So the first thing we have to find is f of negative 1, which we go back up to the top and we see that it's 1. Then we have to find the limit as x approaches negative 1 from the left and the right, and those both equal 1. So therefore we can say f of x is continuous at x equals negative 1 because f of negative 1 and the limit as x approaches negative 1 are the same. And you can do the same for x equals 1. They're both continuous. It's continuous at both of those places. Number 4, you need to factor the top into x plus 9 times x minus 3. Factor the bottom into x times x minus 3. Your x minus 3's cancel. Plug in 3, and you end up with an answer of 4. Last page. Since we're approaching the asymptote, we need to do some algebra. So we're going to multiply both sides by the conjugate. And when we do that, we end up with t minus 7 over this nastiness. The t minus 7's cancel. Plug in 7 for t, and you end up with 1/6. This one gave some people some trouble, but if you think about it, when you plug in 4 for x, then you're saying the limit as x approaches 4 of f of x. This is a limit law, and the limit law says the limit of the product is the product of the limits. So the limit as x approaches 4 of f of x is times the limit as x approaches 4 of x plus 2 equals this. Well, the limit as x approaches 4 of x plus 2 is 6. When you plug in 4, you get 6. So this part right here is 6. Since the product has to equal 12, then this part must equal 2. So therefore, the limit as x approaches 4 of f of x must be 2. Number 7, you need to factor the bottom into x times x plus 3. And then you need to simplify this. Again, the product of the limits. You have to recognize that sine of x over x is 1. That's one of those things you had to memorize. And so anytime you can pull out a sine of x over x, you need to do that. So this limit is 1. And then you plug in 0 here, and you get 1/3, and 1 times 1/3 is 1/3. Number 8 was a pretty bad question. It should have said, at what points does the limit not exist? And the answer is at both points of discontinuity because the limit from the left here, when you plug in 1, is 0, but the limit from the right is 1. So since the left and the right are not the same, the limit does not exist. Same at x equals 2. The limit from the left is 1, but it has no right-hand limit because it's only defined at x equals 2. It's not defined as you approach from the right. So since there is no right-hand limit, actually, I did this wrong. No, it's true. the limit from the left is 1, but f of 2 is 2, and since those are not the same, it's not continuous at x equals 2. Phew, I was right all along. All right, happy studying.